Hey guys, for your homework today, what I want you guys to do is take out the actual lesson notes of 2.2b, similar triangles and slopes. So your only homework today is watch this video or two and fill out the notes with me. So let's go and look at this together. It says in section 2.1, rate of change was the introduction to ratio of rise over run, which is slope of a line, denoted by the variables m. Slope describes how steep a line is. It represents the change in the y value divided by the change in the x value. Similar triangles can be used to find the slope of the line. So what is this slide saying? We looked at a few things, guys. We looked at rise over run. And anytime you hear rise over run, I want you to realize that's the same thing as slope. And that's also the same thing as, what else did we say? We said change in y over change in x. And I'm trying to think if anything, slope, rate of change, rise over run. So that's what we've been looking at. So what we're going to do now is look at triangles to help prove this idea. So let's go and take a look. It says we have this graph right here. It says choose any 2 points that fall in the line. To make your examination easier, choose 2 points that fall on intersections of the grid line. That basically says look at this blue line and see where it crosses on the intersection. So like right here in purple dot would be an example of one, right here would be an example, right here would be an example. What it's saying, which I'm going to draw in red, you don't want to choose a point like right here. It's not an intersection and we can't be exact on what that point actually is. So from the 2 points you chose, create a right triangle. The line will become the hypotenuse of the legs. It will become a hypotenuse and the legs will extend from the 2 points to meet as a right angle. So if I were to take this line, what this is saying is I chose 3 points. We can choose any 3, or any 2 I should say. I'm going to have a line that extends out right here and come all the way down. So here's my right angle. So this part right here is the hypotenuse, which is part of the line, and the legs of the triangle are the red lines that I drew. So let's see, the line will become the hypotenuse and the legs will extend from 2 right points of an angle. So I'm going to be jumping back and forth to this one. It says compare the points that you chose and your triangle with those another student in the class. Discuss the following questions. So what I want you guys to do is I chose these points. I'm going to be your partner in this one, so I want you to choose different points. So it says, did you both choose the same points? I told you to choose different ones, so I wrote no. How are your triangles the same? How are your triangles different? What relationship exists with your triangles? So when you compare your triangles to mine, how are the triangles the same? Well, most likely they're both right triangles. The other thing is they share a hypotenuse. Now, how are the triangles different? Well, they're different sizes. Because I told you to choose different points in mine. Now, what is the relationship between your 2 triangles? In the previous lesson, we looked at dilations. As a quick reminder, a dilation is when I have a shape and we're trying to look for a scale factor by either shrinking or growing it at the same rate for both the length and the width. So we're dealing with a triangle here, so they are proportional. Because they are a dilation of each other. Okay. And remember, since it's a video, if I'm going too fast, feel free to pause it and rewind and rewatch anything, okay? Alright, so it says the graph has a different triangle formed from 2 points that lie on a given line. These triangles are dilations of one another and are similar. So we have 3 triangles. We have this one, which we have 4. We have this one, We have bigger one. 1, 2, 3. Excuse me, we have 3. So how many triangles do we see? I see 3 of them, which I poorly highlighted here. The small one, the medium one, and the big one. So 3 triangles. State the ratio of rise over run for each triangle. So I want to start with the small one. And if I'm starting at this point right here, I want to know how much I go up and over and reduce it. So I'd go over, up 1, 2, 3, 4, 5, 6. So I went up 6, and I'm going to go over 1, 2, 3. Up 6 over 3, which means that reduces to 2. So let's go ahead now and look at the next one in green. I'm going to look at this triangle right here. So if I went up, this would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I just went up 10. And I go over 1, 2, 3, 4, 5. Over 5. So up 10 over 5 also reduces to 2. And the last one I'll look at is in red. That is going to be this triangle right here. And if I go up, I'll be up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I just went up 12 and over most likely 6. 1, 2, 3, 4, 5, 6. Over 6, which also reduces to 2. Does the ratio of rise over run always simplify to the same fraction? And it's yes, and the reason is, since the triangles are dilations of each other, dilations are similar, and therefore corresponding sides will have a proportional relationship. So yes, it's because they're dilations. Because the triangles are dilations of each other, corresponding sides are proportional. Alright. So what that means, just in case you're still a little stuck on that idea, if I were to look at this triangle highlighted in green, and this triangle highlighted in yellow, this side would be proportional to this side, because corresponding sides of similar triangles are proportional. So when we look at scale factor, let's say this one grew by 2 or 3 or 1.5, you would just multiply this side by 1.5 to get this one. Alright, so compare the graphs and complete the following. So, state the ratio of rise over run of each triangle. Simplify your ratios. So, we already know that corresponding sides will be proportional. So what we're going to do is find the rise over run on these, and we're going to see what they equal. Now really quickly, we haven't spent a lot of time on this. Anytime the slope is going from left to right is going down. So if I were to write my name on it, my name's going down right here. That means I'm going to have a negative slope, which means my ratio will also be negative. So how does that look like in our graph? If I start here, I'm going to go to this point all the way over here. That means I'm going to go down. If we're going to go down, that's a negative number. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. I just went down 9, and now I'm going to the right. That's still a positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that reduces to negative 3 over 4. Looking at this one now, I'm going to go ahead and do this one in green. Start right here. I'm going to go down 1, 2, 3, 4, 5, 6. I just went down 6, so it's negative 6. I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. If I reduce them both by 2, that would be negative 3 over 4. Same idea. They have proportional slopes because they are dilations of each other. The two triangles are dilations of each other, and they will have similar slopes. They will have similar rise over run. So let's go ahead and do the same thing here. If I am going to look at these points, this is a positive slope, so I'm going up and to the right. I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went up positive 9 and over 12. So it's very similar, but one was going negative. One was going negative and one is going positive. So let's go and look at this one. Now before I do that, we're going to reduce this to positive 3 over 4. So now let's go ahead and look at this one. I go up 1, 2, 3, 4, 5, 6. I went up 6, and I go over 1, 2, 3, 4, 5, 6, 7, 8. And that is positive 3 over 4. Similar, just by looking at the graph, if we're getting a little confused on the rise of a run, we can always just write our name on it. And going from left to right, my name is going up, therefore I know it's a positive slope. That's just a nice little shortcut to check your answer, not to do your answer. Alright, so if we continue this, what do you notice about the two ratios? One was positive, was a positive slope, which was positive 3 over 4, and the line went up from left to right, while one was negative, and that was the line that was negative 3 over 4. That was the one from left to right that went down like that. They both have the same steepness. One was just positive and one was just negative. So do the lines of the graph both have the same steepness? Yes. So when we explain it, one we just went up 3 over 4, up 3 over 4, up 3 over 4. If those are my steps going up, now the negative steps would, I go down 3 over 4, down 3 over 4, down 3 over 4. The steepness would be the same. So what you need to do is look at the absolute value of the steepness. So if I look at 3 over 4, the absolute value of 3/4 is just 3 over 4. And if I look at the absolute value of negative 3 over 4, that reduces to just 3 over 4. Since I have the same number, I'm going to have equal steepness. So whatever has the greater number of the absolute value will give you the greater steepness. How does rise relate to run of a negative slope, affect the steepness of a line? Well, the negative slope does not affect the steepness of a line only the direction. So compare the graphs and complete the following. So it says state the ratio of the rise of a run for each graph, for each triangle you see. Simplify your ratios. So right here we're going to do the rise of a run. So this one I'm going down, so it's going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just went down 12 and over 1, 2, 3, 4. My rise over run is negative 12 and 4, which simplifies to negative 3. So now when I compare this one, I go up, and there's another triangle in here that I missed, which I'll do in green. If I go up, my rise over run here would be down 1, 2, 3, 4, 5, 6, 7, 8, 9. I went down 9 over 1, 2, 3 over 3, which reduces to negative 3. At this point, guys, I want you to go ahead and do the next few. I'd like you to do graph 2 and B, C as well.